All right, exercise 9J, 9K. We're coming to the end of chapter 9. These are all the skills that you should be learning, hopefully. So you learned all the derivative rules for each of the functions. You have the power rule, you have the chain rule, and then today, product rule and quotient rule. All of those are essentially shortcuts to do it. Instead of doing first principles in the very first exercise, you then use these for those specific functions. So you just need to identify which function you have, and then you apply them. Chain rule, I said, was the bread and butter because you can apply it in all of these scenarios. Okay, that's why you needed to know chain rule. So you had about 2, maybe even 3 sessions to play around with chain rule. So I'm going to assume that your chain rule skills are somewhat decent inside and outside. So when I'm deriving them, I'll just then follow on and say inside, outside. Okay? Here we go. These are your 2 rules, product rule and quotient rule. One is a student-friendly version, and the other one is just written a bit more complicated. Okay? But same idea. The one I usually teach is the VU dash plus UV dash, and then same thing, VU dash minus UV dash. You might have noticed that the order, if you're familiar with your textbook, I switched that order over there. Usually they write it as UV dash plus VU dash because alphabetically U comes first before V. I personally like to write it as VU dash when I first teach my 11s. If I do get up to product rule and I teach them, I teach it as VU dash because it helps them remember quotient. The problem with quotient is that when you're subtracting, order does matter, but addition in product rule, it doesn't matter. So if you did follow UV dash here, and then you followed here UV dash minus VU dash, the answer would be wrong. That's why I normally teach it as VU dash. Okay, so if you look at my notes and you look in the textbook, it's slightly different just because I know the addition doesn't matter about the order. And I do it specifically that way. Why do I highlight that point? Is because mistakes, if they do occur in quotient rule, usually for exam 1, it's the students who can't follow the rule specifically or they don't remember it. So that's why I do it this way. Okay? All right. So now that you got the 2 rules in front of you, you got product rule. It means you take, product means multiplication. So if you've got 2 functions that are clearly multiplying each other, the first one's called U, the second one's called V. And you keep the V, and then you derive the U. You keep the U, and you multiply it to the derivative of V. Okay, that's what the VU dash plus UV dash means. And then similarly with quotient, quotient means division. So division is if you have a function that you can see dividing by another function, U being the numerator function, and then the denominator function is V. It does matter which one's U and which one's V, and therefore the formula is a bit more finicky. So you just got to make sure you remember the order to get them correct. Here are some examples. We're going to do 4 examples together, and on the back of the page, it's a bunch of VCO questions that you can try, and then you can go through the textbook to see if you want to practice more or not. But all of which you need to know all those rules I had mentioned before, pretty much off by heart, and also chain rule should be fluent. Okay? So here we go. Let's do the first example here. Say I give you sine of x times x squared. Often they don't write it that way. They often write x squared sine of x. I wrote it this way so that you can clearly see it's a product rule because there's a times symbol there. But usually they would write it as x squared sine x. And you should then be able to tell this is a quadratic function multiplied to a sine function. That's how you know it's a product rule. Okay? All right, here we go. So we've got 2 functions here. We've got a sine of x, and then we've got an x squared. So here I would say let u equal to sine of x, and let v equal to x squared. I know in the rule is I'm going to have to find the derivative of each one. So let's test your memory or understanding again. What is the derivative of sine of x? Can I please have Viva? Cosine of x, very good. So cos of x. And it's the positive version. Again, you can look at the rules. What's the derivative of x squared? Let's go with Erwin. 2x. Beautiful. So now we've got sine x, cos x, x squared, 2x. Then the rule, we know it's a product rule because they're timesing each other. Product rule is VU dash plus uv dash. So you keep v, times it to the derivative of u. You keep u and times it to the derivative of v. So in this case, if you order it correctly, it should look kind of like this. V times the u dash, and then u times the v dash. So here I would have x squared multiplied to cos x, and that's my vu dash, plus sine x times sine of x. Oh, sorry, times 2x. Sine of x times 2x. And you can probably just stop your answer there. The x squared cos of x. I usually like to write the pronumerals and numbers at the front. So I would usually write 2x sine of x as my final answer. Okay, pretty straightforward for product rule. The next one, I have incorporated a bit of chain rule for both of them, actually. So again, it's a product rule because we've got e to the negative 2x, that's an exponential, multiplied to a cosine function. But within the cosine function, I also have a quadratic. So that's a chain rule. Technically, even inside the exponential, there is a linear. So you can then also, that's a chain rule as well. Okay. Let's see if you guys can do this quickly now. So here we go. So let u equal to the first one, so e to the negative 2x. Let the second one be cos of x squared minus 2x. Let's derive. Let's go with Charlie. What's the derivative of e to the negative 2x equal to? Negative 2e to the power of negative 2x. Beautiful. Again, this chain rule is derive the inside. So if you derive negative 2x, that's how you get the negative 2 at the front. Times with derive the outside, deriving exponential as itself. That's why it's e to the negative 2x itself. That's chain rule there. Yeah. Same thing as I'm going to do the same thing for chain rule for cosine of x squared minus 2x. Let's go with Krish. What's the derivative of v here? That's good. Negative sine of? Beautiful. That's a classic example of chain rule. So derive the inside is what he did first. Derive the inside, that's how he got 2x minus 2. Then he derived the outside, which means he's ignoring what I just highlighted. Derivative of cos is just negative sine, but whatever was inside the brackets, he's had it over here. So this is a classic du dx times dy du. Yeah? And that's what I meant by derivative inside, outside. That's chain rule. Okay? Once you've done that, that's probably the hardest bit. And then now you put it all together. Product rule, v times u dash plus u times v dash. So if I write it out, it should be a big one here, actually. So this would be what? Negative 2e negative 2x multiplied to cosine of x squared minus 2x. That's my vu dash. Plus the other version, so e to negative 2x times this entire bracket here. So I probably would have done it as, what? I might put e negative 2x at the front times with 2x minus 2. And since there's a negative sign there, I'll put a negative in front of e. And that becomes sine x squared minus 2x. But since that's a minus there, I don't have to have the plus. So I can probably just change it to minus. I'm just thinking for the exam, don't leave your answers with a negative power. I probably would just swap it to the bottom. They both have an e to the negative 2x. I would rewrite it as the denominator with a positive power. So it should be negative 2 cos of x squared minus 2x over e 2x minus 2x minus 2 times sine of x squared minus 2x all over e 2x. Technically, you can combine them, okay, because they have the same denominator. So I just did index laws, just flip that to the bottom with the positive power, flip it to the bottom, positive power. These are times, so it's okay. And since I'm subtracting the same denominators, technically you can group them as one. All right. That was product rule. Quotient rule is exactly the same. You just need to identify when you have them. So here we go. I've got the this one done already. because its power rule is pretty straightforward. Top one is U, bottom is V. You can copy that one down or you can try it yourself. I'm going to do the second one, so B, so it becomes more obvious. So here we go. Numerator is your U, so we then have U equals to 3x squared plus 1. V is the denominator, so I'm going to call it cos x. And it does matter which one's V, so the bottom one is always V. Okay? Get them wrong, the whole thing's wrong. Here we go. Let's derive. Let's pick another two students. Let's do, what's the derivative of 3x squared plus 1? Can I please have Una? What's the derivative of 3x squared plus 1? Beautiful. And then let's go with Aryan. Derivative cos of x. Oh, well, you were correct. It was just negative sine of x. Yeah, so if it's cos x, derivative of that will be sine, but it's just negative. So it'll be negative sine of x. Okay? All right, so we've got the derivative functions for both. Again, now doing quotient rule, I like to keep it as VU dash minus then UV dash so you don't get the order wrong. So some of the jokes I usually say last year, I'd say Victoria University first, and then it keeps them to remember. Because most students generally want to say, they want to do Melbourne Uni, and I'm like, Vic Uni first. I'm like, ha ha ha, and then remember it. But whatever floats your boat. I think either university is fine. But at the school that I was teaching at, University High School, we were just opposite Melbourne Uni. So when I said Vic Uni, a lot of the students there had a plan to go to Melbourne Uni. That's why it stuck with it more. For you guys, it probably wouldn't be the same sort of a joke. All right, here we go. dy dx equals vu dash minus uv dash. So again, I've got v times u dash. So it should be 6x times cos of x minus is the key part. And then u times v dash, which is negative sine of x there. So it should be negative 3x squared plus 1 times negative sine of x. Oh, so we should be careful there. So negative sine of x there. Technically, double negatives will become positive later, which I'll do that later. And you divide all of that over v squared. So it should be cos of x. And if you prefer, you can use square brackets squared. Sometimes people write it as cos squared of x. You can write it that way too if you prefer. So instead of writing it the way I have done, you could write cos squared of x. And that means the same thing. Okay. I do it in the brackets to make it clear for the students who generally aren't familiar with squaring coses or seeing cos squared of x and they know what to do here. That's why I write it that way. But generally, that's how I see it in textbooks. Okay. All right. To finish off, double negatives is positive, and let's see if there's anything to factorize. No, nothing I can factorize. So I'm going to leave it as 6x cos of x plus 3x squared plus 1 times sine of x. Notice I introduced a bracket for 3x squared plus 1 because that came together. Okay, so if you don't put the brackets in, then it looks like you've got 3x squared plus 1 plus sine x. Makes it wrong. Over cos of x all squared. There you go. So none of these examples I've given to you for the quotient rule had chain rule in it. This is as basic as you can get, and probably your textbooks are more similar to that. I do want you to practice, especially in more of the recent years, they do combine product quotient along with chain rule. So you've got to be fluent doing chain rule the way we did for product up here. Okay. But those are your samples there. I'm going to just freeze the screen there for you if you needed to copy the first example. And if you want to have a try, on the back of the page are some VCA examples of exam 1. And you can see the variety of how they would do it. And you can see the difficulty from early 2000s to as we go further, they start implementing more chain rule problems in there. Okay, so you can see how much simpler it was beforehand and how they're trying to increase the difficulty. So if you look at 2021, that one, there's a lot of complexities there. That's technically product rule, but then it's got a power of half. So you're dealing with fractions along with the chain rule within them. Yeah. Versus 2006. One's an X, one's a tan. In fact, the examples I did was a lot harder than that. Okay, so you can see how after 20 years, how much of a difference things have become. And that's what I'm saying as a bare minimum. The skills that I'm teaching you from the textbook is bare minimum. It is required that if you look at their past exams of recent years, they are increasing it, and I'm seeing it more like these versions. Okay, so therefore quotient rule, chain rule must be your bread and butter. So even just get question 1 and question 2 maybe. Those are your basic forms. Okay. All right, there you go. That's why I said it's your bread and butter. Chain rule is your bread and butter. So if you haven't mastered chain rule, that is your first thing to do. Otherwise, get some practice with VCO exams and then you can move on. That's the skill bit. Okay. The rest is interpretation, application in chapter 10. But you've got to get your skills in first. All right, I'm going to stop the video there and I'll pop around to see if I can help anyone with derivatives.